representation of numbers in Python. So I think I have finished off discussing integers. Have I discussed the floating points, or I just have discussed integers and I left?
Yes, ma'am.
Okay, integers is over, right?
Yes, ma'am. Yes, ma'am.
Okay, fine.
Yes,
now let us get back to the terminal. So let me open the terminal and then we'll get started. So I hope everyone can see the screen.
Yes, ma'am.
Yes, ma'am.
Okay, so I opened the Chevron prompt for you. So the interactive mode of Python. So wherein here I started showing you what is an integer and what are the syntax errors that you can make while declaring a number which is of integer type. Now let us look into what is a floating value. Say for example, I'm saying x is equal to some 23.6. Okay, so this is a floating point literal. 23.6 is a literal and x is a variable. So I think I needn't tell you what is a floating point because you people are aware of what are data types, various data types into float, char and all that in your C programming. So you already have learned it. So whenever you have a decimal value, decimal point and some associated fractional part, then it is considered to be a floating value. Okay, so 23.6 is a floating point literal. You can also have some numbers after this decimal point, and the permissible numbers after this decimal point is 15. Okay, so that you can check also along with the language, like what is the precision, so that you can check. I'll tell you what is the attribute that is used to check the precision and all that I'll tell you. Okay, so this is a floating point literal and a variable. Now you needn't, like in C, you needn't say float x and all that. Here in Python, you needn't give the data type. Okay, so automatically based on the literal, the type of the data type is already assigned. Okay, so based on the data that you give, the literal that you give, x becomes that of that data type. Now, if you want to check what is the type of x, it will show you that it is of a float class. It belongs to the float class. Okay, so automatic allocation of the variable to a particular data type happens internally. So within Python, so you needn't do that. So since x is equal to 23.6 and some decimal point and some fractional part is here, it is considered to go a floating point data. Okay, fine. So next, let me just print it and show you. So I simply can say print x and the value of x will be printed. Fine. So you can see that there is a decimal point here, and before the decimal point there is something, and after the decimal point there is something else. Okay, right. So the number before the decimal point is considered to be the integral part, and the number after the decimal point is the fraction part. Okay, so this 655 and all that is the fraction part. So if you want the number to be splitted into integral and the fractional part, you have a method which is called as modf. By using modf method, you can actually separate the integral and the fraction part. So here the variable is x. So I'm giving it in the modf function. So let me do it in the print statement. And another thing is this mod f. So you can see that I got a name error as I have given the modf function. Because the modf function is there in the math module. Okay, so to use the methods that are there in the math module or any of the modules, by fact it can be a system module, sys module, or it can be a math module, or it can be a turtle module, or any module by fact. Okay, so you need to first import the module. After that only you will be able to use the methods that are there in the module. It is similar to, like for example, if you want malloc, calloc and all that, they are functions. I'm just connecting you to the C programming because you people are already you know that language. So if you want to use malloc and calloc, you need to include header file which is standardlib.h. Okay, so if you are not including standardlib.h, what happens is your malloc, calloc and all that will not function in your program. They will not be able to work. Okay, so to make them work, you need to bring in the code that is there in standardlib.h. In the similar way, to use this modef function, I need to import the module which is math module. So I am saying from, so I simply said from math import. Okay, so from math import modef. Okay, so now the import is done. So modef is imported into this particular environment. Now what I'll do is I'll try to find out the integral and the fractional part of x. Okay, so as you can see that so 23.0 is the integral part of the floating point number. So you can see x has 23. And then coming to the fraction part, so I got this as the fraction part. If you can see this, it will be more than 15 digits that will be there after this decimal point. So modef is used to actually, give you the fraction and the integral parts of a floating point numbers. In the similar way, if you just wanted to know like how many digits will be there after the decimal point, you have an attribute which is called as float underscore info dot dig. So this is an attribute from the sys module. So you can use that attribute to know the number of digits that are permissible in the fraction part of a floating point number. So let me actually import sys module because this attribute is there in sys module. So I am importing sys module. And now I am trying to say sys dot, I said float underscore info dot dig. Okay. So if you just do that, so it is showing me that 15. Okay. So what is 15? 15 means that after the decimal point, how many digits will be there. So it will tell us that. Okay, so 15 digits you will be, for till 15 digits you will be getting accuracy. After that 1 or 2 digits will be there, but without accuracy you will get. So 15 you will be getting accurate results. Okay, after the decimal point. So this is float info regarding the digits. Okay, so that's it regarding the floating point number. So what did we have seen? What we have seen? We have seen how to declare a floating point, floating variable, and what is a literal, floating literal, and this is the floating literal, which will be having a decimal point. I can also say x is equal to 10 dot. Okay, so even if I didn't put anything after this dot, it is okay. It will consider it to be 0. So when I try to print x, so I'll get 10.0. Okay, so even if I ignore that fraction part here, it is okay. Syntactically, it is correct. It will add 0 after it. Okay, so this kind of representation is also valid. And so say I'm saying x is equal to 2 underscore 34. Then I'm saying dot 89 underscore 90. Okay, so and then say I'm printing x. Okay, so you can see that underscores are also permitted in a floating point number. I already told you yesterday that underscores are used for increasing the readability of a number. So to actually increase the readability of a number, here say like it's a very small number, but I just wanted to tell you that underscore is also permissible in a floating point number. Okay, so this is all about the floating number representation in Python. Now let us move on to Boolean. So say I'm having x is equal to, so true. Okay, Boolean literals are only two literals are there for Boolean. One is true and the other one is false. You can assign true or false, that's it. And Boolean is a type of data which comes under integers data type, because the true will be internally represented as 1 and false is represented as 0. So true and false are internally represented in an integer format. Did I start recording? Okay, fine.
Yes, ma'am.
Okay. I just had a doubt whether I started recording. Okay, so I said x is equal to true. In the similar way, I can say y is equal to false also. Okay, fine. These are the only two literals that are possible for a Boolean to represent a Boolean number. For example, I'm saying x is equal to, I said all lowercase. So here for the first true, I gave the first letter to be capital T. But here when I said all lowercase letters are there given for true. So you can see that I'm getting a name error which is saying name true is not defined. So always remember that the first letter in the Boolean literal is capital letter. So that's the case with the false also. The first letter will be capital letter. So you cannot give all lowercase. Of course, if you just connect to the concept of keywords from your C programming, in your C programming, you do have the keywords. 32 keywords are there in C programming. All the 32 keywords, if you just take a look, everything is in lowercase. There is nothing in uppercase. So all the keywords in C programming are in lowercase. But if that same question comes to you for Python, all the keywords are not in lowercase. Okay, so there is an exception over here for the true and false, wherein the first letters are capital letters. Okay, right. So this is one general mistake that the students make. They think that true, it's a case sensitive. Yes, of course, Python is case sensitive. So you think that everything is in lowercase, and they tend to give in this manner, and this will give you an error. Okay, fine. So such type of syntactical errors can be avoided by just practicing these things regularly. Okay, so this is regarding the Boolean. Okay, well, fine. Now we'll see how to give a complex number. So we have seen integer, we have seen float, we have seen Boolean. Now let us look into complex number. Fine. Okay,
Yes,
so we know that complex number will be having a real part and an imaginary part. So again, I'm saying a is equal to, say, for example, I just wanted to give a complex number. So I'm saying 2 minus 9j. Okay, so this is how I represent. You cannot say 2 minus 9. You cannot ignore a j over here. If you ignore a j, what happens is it becomes, it will take 2 minus 9. Okay, so it will give you a 7. It will consider it in that manner. Then that is an integer, not a complex number. So this j is mandatory for you if you want to represent a complex number. You can also give a uppercase a j. Okay, so I say 4 plus 8 uppercase j is also permissible. Okay, so lowercase j or uppercase j is also permissible. Now, can I put a I? So let me show you whether you can put an I or not. So I am putting an I over here. When I put an I, it is saying that it's a syntax error. Generally, when we use the complex numbers in mathematics, we tend to give an I because this is what is we are habituated to giving an I. But because it's an imaginary part, so we generally tend to give an I. But you would have to give a J only, not an I. Okay, fine. This is again another syntax error that the students generally tend to make. So put a J, which can be an uppercase or it can be a lowercase. Okay, fine. J need to be there. Okay, so for example, I'm saying H is equal to 9J. This is also okay, which is not having the real part. It's just having the imaginary part. Okay, so if I print H, what will be the result? The result will be 9J. Okay, so if I print A, what will be the result? Okay, so let us take a look. So when you have the imaginary part and the real part, it will be giving you an output in terms of a bracket. But if you're just having the imaginary part, it will just give you the imaginary part as it is. Okay, so this is how all this kind of representation is very important, because these are the questions that you get in the screening test before your placements. Okay, so when you attend your placement examinations, before the the written test that is conducted before the interviews. Okay, in that particular interview, written test, these kind of questions you will be getting, which will be like you know it but you really don't know it. Okay, so they'll be confusing. So this kind of understanding is needed whenever you're learning a programming language. So this is how you represent a complex number. And for example, if you want to know the type of a complex number, you will be using this type method. So type method is used here. So I'm saying type and then I said A. So when you see A is a complex number, so here it is saying that it is class complex. Okay, fine. So type is a method in which you will be passing a variable which will give you a complex number, saying that A is a complex number. For integer, it is saying it is of class integer. For float, it's saying float, and then for Boolean, it is saying bool class, and for complex number, it is saying complex. Okay. Now, say for example, I want to extract the real and the imaginary part of this complex number. So you do have two attributes. Okay, so the first attribute is the real attribute, and the second attribute is the image attribute. So I'll just show you that on this particular A. So I'm saying I can say A dot. So I want the real part. So I'm saying A dot real. So what is A? A is this one, right? So 4 plus 8j. So 4 is the real part. So it is showing me that 4.0 is the real part. You can see real is an attribute which you can use it with a complex number, wherein which will extract the real part from the complex number and print the result for you. In the similar way, I can also use image. Okay, so image is an attribute which will actually retrieve the imaginary part from the complex number. So the imaginary part from the complex number is 8 over here. So 8 is retrieved. So you can actually segregate, or you can separate the real and the imaginary part from the complex number by using the attribute real and image. Okay, so that's it regarding the complex numbers, and all the arithmetic operations are possible on all the integers, floats, and then the complex numbers, not on the booleans, because it's only true or false. It just makes a decision. But the rest of the numbers, like integers, floats, and the complex numbers, all the arithmetic operations, like all the 7 arithmetic operations are possible. Okay, that exercise we'll be seeing in the second experiment. So this is the number representation. Now we'll get into one more very important point for representing a numbers. So what all we have seen, for example, I'm saying x is equal to 67. This 67 over here, is a decimal number. What is meant by a decimal number? A decimal number is a number which will be having the digits from 0 to 9. Okay, any number that will be having any length, the number can be of any length, but the digits that you can see in a decimal number will be like the numbers through 0 to 9. Okay, so that is called as decimal number. So here 679 is a decimal number. It's a decimal number, and we are habituated to the decimal system. So if we count money in decimal system, we represent anything in decimal things. Okay, the count or the arithmetic operations, everything is performed on the decimal numbers. We are used to decimal numbers. But in computers, sometimes for certain kind of data, certain kind of representation may be needed. For example, if you want to represent the pixels, or if you want to, because in computer science, we do have different kinds of formats, different kinds of information to be maintained. So for example, if you want to represent the pixel values, representing it in hexadecimal or the binary format will be very useful. So in that way, the numbers can be represented in a different way. The first one is you can represent the numbers in binary. Okay, and the second way is like you can represent it in octal, and the third way is like you can represent it in hexadecimal. Okay, binary means that the numbers will be only 0 and 1. So whenever you're representing a number, you will be representing it only in 0 and 1. And octal means that you will be representing a number from 0 to 7 only. Okay, so that is octal representation. And if you're representing a number from 0 to 9 and from A to F, it becomes hexadecimal, which is 16. Okay, octal is 8 base, binary is base 2, octal is base 8 and hexadecimal is base 16. Okay, and the permissible digits that will be there in binary is 0 and 1, and the permissible digits that will be there in octal is from 0 to 9, 0 to 7, and in hexadecimal it will be from 0 through 9 and then from A through F. Okay, so it can be capital letter A to F, or it can be lowercase a to F. A being capital or lowercase, it's not mandatory. And how do you represent them here in Python? Okay, so here in Python you're having three methods. The first one is to represent a binary, to convert hexadecimal to binary. You'll be using the bin method. So bin method is used to actually convert whatever you give inside this parenthesis will be converted into the binary format. And the other method you have is the octal method. Whatever you give inside this parenthesis will be converted. It can be an hexadecimal format, or it can be a binary. Whatever number you give inside this parenthesis will be converted into octal number. In the similar way, you're also having another method, which is hex method. So this hex method, whatever you give inside it will be converted into hexadecimal format. Okay, so these are the three methods that we are going to look right now for converting one format representation into another format representation. And now some other, how do you represent a binary number? Say for example, 8, if you take 8 is a decimal number, right? How do you represent 8 in binary? Okay, so in binary 8 is represented as 1000. Okay, so this is how you represent in binary. But if I say x is equal to 1000, your compiler will get confused whether it is 1000 or it is binary number. Of course, it's a confusion, right, to your compiler. So to make it clear that it is not a decimal number, it is a binary number, you do have to prefix it with a representation which is 0b. Okay, so this representation you have to give. So whenever you have prefixed 0b before the number, it makes it understands, your interpreter understands that now this 1000 is a binary number, not a decimal number. So this kind of prefix need to be there. You can prefix it with a B, a capital B, or you can also prefix it with a small letter B. Okay, so it's okay. Either ways is okay. And the next one is like, how do you represent a number in octal? Okay, so in the similar way, octal number need to be preceded with 0 and O. So I have to give a 0 and O, or else I can give a 0 and capital O. So both are permissible, and you have to prefix it, not suffix it. You have to put it before the number itself, and you cannot say that 0O, and you cannot say 789. Okay, so will this become an octal number? It is not an octal number, because as I said, like, the permissible numbers are only from 0 to 7. There won't be 8 or 9 inside an octal number. So this is a very common sense question, so that they will ask you for interviews before the examination. Okay, so do not think that 0 and O, and after that any number taking any number will not make it an octal. Okay, so octal numbers will be there only from 0 to 7. Okay, so there won't be any 8 in octal representation. So 8 will not be there, obviously 9 also will not be there. Okay, so if I give 765, this is an octal number, because 7, 6 and 5, all these are permissible in an octal number. So that care you need to take whenever you're representing an octal number. In the similar way, you can also represent an hexadecimal number with a 0 and x. It can be capital X or small x. Anything is okay. Okay, so you have to just prefix it with that. Now, for example, I can say 3 and then capital A and capital C and capital B. This is of course an hexadecimal number. Okay, because from 0 through 9 and then from A through F, everything is permissible. But I cannot put a Z over here, because Z is not there in hexadecimal digits. Okay, so this will be wrong. Okay, fine. All this care you need to take, and you can represent a number in any of these formats. You can represent it in hexadecimal, or you can represent it octal, or anything. I'll just show you a simple representation. So I'm saying 0, B, and I'm saying 1000. So you all know that 1000 represents an 8. If I want to print x, now let us see what will be the output of it. It is saying always the result will be printed in decimal format only. Whatever representation you are taking, it can be a binary, octal, or hexadecimal. Whenever you want to use the number, then the number's decimal representation is only used in the expressions and also in the when printing the output. So this is the output of it. So 8 is printed. You know that 1000 is 8 in decimal, so it is printing it. So this is valid. Like you can say x is equal to 0b and all that is making it. But in case if I take off this 0b, it will consider it to be 1000 only. Okay, so it is very important that you give, if it is a binary number, it is important that you give zero prefix 0b before it. Okay, now it is taking 1000 only because it is considering this to be a decimal number. Okay, so 1000. So the value of x will be 1000 here. Since I have prefixed it with 0b, it is taking it as a binary number. Okay, so this is how you represent a binary number. In the similar way, I'm saying x is equal to, I can say 0 and O, and then I'm saying 7 and 6. Okay, so then I said print x. Okay, you can see the value of this is 62. Now you will be getting all the result in the decimal format only. Say for example, I'm putting on 8 over here. Now see, it is giving me a syntax error. 8 is not permissible. It's not in the octal numbers. So it is not there. So it is giving me a syntax error. So you need to take care of this because these are important things. If you are doing this mistake, it means that you don't know the programming language. So do not make that mistake. Okay. So I said 0x and then I'm saying it's a. Okay, that's it. So I just wanted to print a. So let us see what x, let us see what will be the output. So the output is 10 because I said from 0 to 9 and then a to f, right? So a is 10. Okay, so in the similar way, b will be 11 and all that. F will be 15. Okay, right. So this is how you represent numbers. You can do it in this format also. You can do it in binary. You can represent a number in octal. You can also represent a number in hexadecimal. Now let us try to use the methods. Okay, fine. So the methods are conversion methods are like bin, hex, and oct. So let me just show you that. So I have a number. Say for example, I have x is equal to 97. Okay, so now I'm using a hexadecimal hex function wherein I'm putting x and I want to get the result. So what is the hexadecimal representation of 97? 97 is in decimal format and I just wanted to convert this decimal base 10 into base 16. So I got 0x61. Okay, right. This is what I have done. Now let me convert the same number into octal. So I'll say OCT and then I'm passing x into it. So you can see this is how the number, the representation of 97 in octal. 97 is decimal and I'm passing it into it. In the similar way, you can also pass hexadecimal into octal and convert it into octal. Say for example, I'm saying 0x61 and when I now I have passed hexadecimal into oct function and I want to convert it into octal. So it is converting it. Okay, any format can be taken into any converted into any format. So it is not like only you have to give the decimal format and then convert it into various types. No, the bin can be given, oct can be given, hex can be given, anything can be given into any formats. Any conversions from one format to the other format is possible. Okay, say for example, I want to convert it into bin. So for example, I said bin and then I'm passing decimal into it. So you'll get in 0B1000. Why I'm giving 8 all the time is because you people can easily connect it to the answer. Okay, rather than giving a big number, here the point is to make you understand how it works. Okay, so that's the reason I'm taking a smaller number which is known to you so that you can connect to the concept very clearly. Okay, so this is how you can convert from one format to the other format. Okay, so I have shown you how to convert it from decimal to hex and decimal to oct. In the similar way, hexadecimal can be given and converted to oct, and a decimal can be converted into binary and all that. Okay, or for example, I'm saying if I just wanted to get the ASCII representation of A, I can use this odd function. Okay, so wherein I passed lowercase a, and it is saying that the ASCII value of lowercase a is 97. In the similar way, I can also pass capital A here, and the capital A's ASCII value is 65. So you know ASCII chart. So I think you know what are the ASCII values for capital A and lowercase a. So this already you have studied in your C programming, American Standard Code for Information Interchange. That's the abbreviation of ASCII. So we already know this. Okay, so A and A, you already know it, because you can construct what is B and C and from, if you know the starting of ASCII value of A. So this we know. Okay, so for lowercase it's 97 and uppercase it's 65. In a similar way, if I just wanted to know what is the ASCII character for a specific value, okay, so you can also use this CHR. Okay, so CHR, and then I'm saying 97. Okay, so I'm passing the ASCII value to get the character. So when I pass 97 into CHR, so I'm getting the character. So the character is A. Okay, so this is the ASCII character associated with the ASCII value 97. So that's it, girls. So these are all the functions that you can use to convert one number representation into another format. So this ends your first experiment. I hope everybody understood this. Do you have any questions? You can ask. Or shall we move on to the second experiment? Is this clear?
Yes, ma'am.
Yes, ma'am. Clear, ma'am.
Clear. Okay, let me get two confirmations. Okay, I'm not getting a few more. I need a few more confirmations to move on.
Clear, ma'am.
Clear.
Clear, ma'am.
Is it too fast for you, or it's okay? The pace is okay. You're able to follow it or not?
Yes, ma'am.
Yes, ma'am.
Yes, yes. The pace is okay, right?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Okay, so this is all that you have to do, but provided that you should not show it in the this particular interactive mode, you have to write a program. Like for example, what you have to do in your examinations is that so get to the terminal. Okay, get to the gedit terminal. Okay, so say that it's, if you want to represent a number, so I'm saying gedit and then number.py, and so the gedit screen will open for you. So can you see the gedit screen?
Yes, ma'am.
Is it visible?
No, ma'am.
No, okay, because I, okay, once you do that, what will happen? It will take you to the gedit screen, right? So this is your gedit screen. Okay, herein you have to write all the programs. So you have to say import sys, and then from math, what I'm doing from math, I'm importing what is the method that I want to import from math? Can anybody tell me?
Mod.
It's mod f. Okay, so I'm saying from math import mod x. So the first one is I want to show integers, right? So tell that integer number representation, and then you say x is equal to some 45 or whatever. Okay, so then print. Um, so give all this. Okay, print x. Okay, and then you're saying print type of x and all that. Okay, so all this stuff related to integers you will be typing in, and after that you'll come to the floating point numbers. So you put a comment over there saying it's float number, and then you start off. Okay, so then give 78.67 and all that related to floating point you will be writing here, so which I already have told you. So this is again the Boolean representation, write all that for Boolean. and then for the complex number, write everything pertaining to complex number, and then finally talk about the number conversions, okay, and number conversions, okay, and all the methods that you have seen so far, you will be listing out. And once you have written all this code, lines of code, then save it, okay, and then close it, okay. After doing that, what you have to do, come back to your terminal back, okay, back to your terminal back, and then execute it, okay. So how to execute it? So I'm saying Python 3 and then name of the program, so which is number.py. So it will start executing for you and it will show the result. This is what you have to show in your internal and external lab examination. I think I'm clear on this.
Yes, ma'am.
Okay.
Yes, ma'am.
So let us move on to the second experiment. So the second experiment is, let me get you to the interactive mode again. Okay, fine. What is your second experiment? Second experiment is to perform arithmetic operations, okay, and the complex arithmetic operations. Arithmetic operations. So as we know, okay, as we already have studied this in our theory part, that there are 7 operators which are pertaining to arithmetic operations, and these 7 operations will be used accordingly. Okay, so in evaluating any expression that you take. What are the 7 operators? The first operation is the addition operation, so which you already know, and the second one is the subtraction operation, and the third one is the multiplication operation, and the fourth one is the division operation, and the fifth one is the modulus operation. So all these you know from your C programming. And coming to the sixth one, it is exponentiation operation. Exponentiation operator, and the seventh one is floor division. Okay, so all these are the 7 operators, arithmetic operators that Python supports, and so we need to show all these operations performed on different kinds of numbers. Okay, so let us see all these operations. Now coming to the first operation, I'm just taking some integers and working on it. So I have taken 45, x to be 45 and y to be some 89 or whatever. So I have taken x and y, and now I'm performing x plus y. Okay, so as you can see, this is an arithmetic operation where plus is used to represent it. Okay, so the addition operation is a plus over here, so which you will be finding it in your keyboard, and you just need to press it. Okay, so this I think I needn't stress on it because you know it, and this gives the sum of x and y. This plus works in a different way when different kinds of values are given. For example, I'm saying Sudha, which is a string, and I'm saying plus, plus, and then I'm taking another string, which is, say, for example, Seenu. Okay, so I have a string and then I have a string over here, and I do have a plus over here. And if you're trying to concatenate a string and a number, you will get a type error. Okay, anyway, we have seen that in exception handling. So here I am taking 2 strings and I'm trying to perform operation between it. So what happened is here, this string and this string are attached together. So it has become Seenu, Sudha and Seenu. Now in the similar way, here plus is acting in a different way, and here plus is acting in a different way. This is again a very, very important interview question. What is operator overloading? And this is what is called as operator overloading, where plus in this way, when applied on integers or applied on floating point numbers or applied on complex numbers, all these arithmetic operations can be performed on 3 kinds of data that we have seen: integers, floats, and complex numbers. On anything, these operations can be performed. You can try it out. And at this particular juncture, a plus is behaving like an addition operator, but here in this particular point, it is acting like a concatenation operation, where it is merging or combining or adding, appending the other string to the first string. Okay, so this is what is called as operator overloading. You can give this example if possible when the interviewer asks you for what is meant by operator overloading. So this is regarding the addition, and say for example, I just wanted to subtract it. As of course, it's a simple minus symbol that you find it on the keyboard. You can just use it, and then the multiplication. So I'll be just giving a x into y. Okay, so the star asterisk symbol, which will act like a multiplication operator. In the similar way, I can also use a forward slash. So this is a forward slash, not the backward ones, which will actually do the division for you. So this is division, and you can see that for the division there will be like the numbers. You can see that this is the first 5 numbers, this is the next 5 numbers, and you can see this is the next 5 numbers, and additionally you got one number. Okay, so you can see 15 till 15 digits you will be getting accurate result. Okay, till here you will be getting accurate results, one will be inaccurate, this 9 will be inaccurate results that you get. Okay, so you can just count on the 15 digits that you get after the decimal point. So this is division, wherein it will give you the quotient. Okay, so in the similar way, modulus will give the remainder for you. So I'm saying x mod y, so which has given me a 45. And in the similar way, I can also use exponentiation, and the symbol is double asterisk. So I can say x double asterisk y, so which will say that it's power of x to the power of y. It means that. Okay, so I got some answer like this. So this is an example of how your Python is saying that integers are unlimited precision. So you can see here, like this kind of answer, you will not get it in your C programming, because yesterday I already showed you the range of integer is 2 bytes. Anyway, the memory representation of the data types in C programming depends on the compiler that you're working, but it will be 2 bytes maximum. In some cases, it will be 4 bytes. But there is a range for integer wherein the number will be only within it. You can see that this entire thing is an integer number. It is a single number. Okay, and so I think you got an answer for what I have told you in the previous session, wherein I said like for integers there is an unlimited precision. There is how much ever you type it, it will consider the entire thing to be a number. So this is the answer for it. And let us look into the next operation. So this entire thing is the number. This whole thing is the number. Okay, fine. And next is the floor division. Floor division, you will be giving 2 forward slashes. Yes.
Ma'am, for complex arithmetic operators, is this program is enough to write for exams, ma'am?
No, it's not over yet, no. It's not over yet. I'm still working
We have
on
to
it.
write int and input like that, ma'am. Int
Uh,
of input.
yeah, you have to give it in that way. You
Okay.
have to give it in that way. I'll show you. Okay, I'll tell you that also finally.
Okay.
Okay, right. So this is floor division. So floor division, for floor division, you will be using 2 forward slashes and then followed by y. Okay. So I got a 0. Okay. So you can see that I got a 0 over here. In the similar way, I can also perform all these operations on the floating point numbers. You can see that integer divided by integer is giving me an integer for the floor division, but here I'm getting a floating point. Okay, here that's the difference between floor division and the division. What is the difference? Here x is an integer, y is also an integer. When I did x divided by y, integer divided by integer, I'm getting a float. This is not the case in your C programming. Int by int will give you an int only. Okay, but here it is giving you a float. This is one difference between floor division and division. And for the floor division, since it is into floor division here, I'm getting a 0. Okay, so the fraction part you won't be getting in the floor division. Okay, but say for example, I'm having 6.7 and then I'm doing a floor division of 2.2. So you can see that I'm getting 3.0. Okay, so the floating point representation will be given for float by float, floor division by floor division. Okay, but for integer and integer, I'll be getting an integer only for the floor division. Okay, so this is the difference. between the division and floor division. Now coming to the perform different complex arithmetic operations on numbers in Python. So let me tell you how to read in a complex number, and then I'll show you how to work with addition, subtraction, and all that with the complex numbers. If you want more detailed thing about what is a complex number and all that, I have made a video. I think you people are there in Seenu and Sudha channel. You can watch my lab experiment 2, wherein I have given a detailed example on what is a complex number, and I just made some calculations and shown you. Have you watched that video?
No, ma'am.
No, you can just look into it, wherein I discussed what is a complex number. And since you people are triple E students, I think I have taken an example of application of complex numbers, which works in triple E, okay, electrical engineering. So I think that video will help you more rather than the CSE students. After the class, I think you can watch that if possible. Okay.
Okay, ma'am.
Yes, ma'am.
Okay, it is lab experiment 2. Okay, so lab experiment 2, wherein I discussed that. Okay, well, fine. Now let me get into the terminal and show you how to read in a complex number. So I said gedit. So let me give a name to it. So I'll be giving number.py. So I'll work on the same file, in the same file. Okay, well, fine. So I said I'm taking two. I'm taking two complex numbers because I need two complex numbers to perform the addition, subtraction, multiplication, division, and all that. So I'm saying A is equal to, so I can use this typecasting, okay? So complex, like how we are saying int and then you are saying input and all that. In the similar way, I can say complex, wherein it will take in read in the complex number from the user. So I said enter A, so which will be a complex, reading a complex number from the user. I can also do it in this way. Okay, so wherein I am saying B is equal to, again I can say complex, and then I said input, and then I'm saying enter B. Okay, so both will be a complex number. So I'll be saying A is equal to a complex number and all that. Let me print A and B for you and show you first how this is read, and then we'll move on to the operations. Okay, so I'll show you two methods. Okay, in my video also it is very clearly shown, but anyway I need to take class for you. I'm showing it. Okay, I just have showing you like how to read in. So let me get back to the terminal. Can you see the terminal?
No, ma'am.
Terminal is not visible to you. Did you see me
No,
typing in the
ma'am.
gedit? Did you see me typing in the gedit?
No,
Yes,
ma'am.
ma'am.
Can you see the terminal, girls?
Yes, ma'am.
Okay.
Yes, ma'am.
Can you see the gedit screen?
Yes, ma'am.
Yes,
Yes.
well, ma'am.
Okay, what I have done is I said A is equal to complex, and then I said input enter A. This is how I will be reading a complex number. Okay, I'm just printing the complex numbers for you on the screen. I haven't gone to the arithmetic part. I'm just showing you how to read in a complex number. So I'm closing this. Now can you see the terminal back?
Yes, ma'am.
Yes. Now I'll execute it and
Yes,
show you.
ma'am.
Okay, now I'll execute and show you. So I said Python 3 and then number dot Python py. So what's telling me? Okay, there is a double quotes. Okay, this is single and this is double. Okay, anyway, fine. Right. Okay. Can you? Okay, can you see the terminal?
Yes, ma'am.
Yes, ma'am.
Okay, now I'm reading in a complex
Yes, ma'am.
number. So I can directly read in a complex number. I'm saying 3 plus 4j. Okay, I can simply do that. And for B, I'm saying 7 minus 9j. Okay, I can also give a capital J. Okay, so this is how I'll be reading a complex number. So reading a complex number, is it clear?
Yes, ma'am.
I have another way also to read the complex number. Let me show you that. Okay, so what I can do is I'll be taking off this B and I'll show you another method of reading a complex number. So what I'll do is I'll take B real part. I'll be reading it from the user, just like how I read the integer values. So I'll be saying int of this part. So I'm saying enter the real part of B. Okay, fine. I think this should be clear. In the similar way, I'm saying read the imaginary part of B. So both are integers. Okay, so now I just wanted to uh, convert it into a complex number. So I'll say B is equal to, so I'll typecast it now. Okay, so I am saying complex, and now I am passing the real and imaginary parts into this complex function. So I'll say B real, comma, B image. Okay, so this is what I have done, right? So now it will be converted into a complex number. So I needn't give that I, J and all that. In the first case, I have to give this J, but in the second one, I needn't give it. I can just read the real part and the imaginary part and put it in the complex function. So automatically both the integers will be considered to be the real and imaginary part of the complex number. It will automatically add a j for you and give the result. Okay, so now let me show you this one. So as I execute it, so I'm executing, it's asking me to enter A I have directly, I can directly take it because that's what I have given. So I'm saying 8 minus 2j. But coming to the B complex number, it is asking me to enter the real part. The real part is 5 and the imaginary part is 2, say for example, or else I can also say it is minus 2. So what happens is it is converting it into a complex number. So this is what directly I have given the complex number. This is wherein I have read the real and imaginary part and converted it into a complex number. So is this clear to everyone?
Yes, ma'am.
Okay. Now what are the
Yes, ma'am.
operations that you can perform on the complex numbers? The operations that you can perform are addition, subtraction, multiplication and division. So these are all the operations that you can perform simply like how you have performed the operations on the integers. In the similar way, you can just perform it. But the internal calculations and all that I have shown it in my video, you can just go through it, you'll understand it. Okay, it is a detailed video wherein I discussed about what is a complex number and how the arithmetic happens. And it is very useful for especially the electrical students. Okay, I'm doing the division and this is division. Okay, so that's it. I simply read two complex numbers. The reading part is complex over here, but I think I have shown you very clearly how to read in the complex number. And here we are performing arithmetics on the complex numbers. That's it. This is the program. And before this program, what you have to do is you have to show all that operations that I have shown you. Like I said, x is equal to some 12 or and then y is equal to some 56 and all that. Then all the basic 7 operations you have to write in over here. Okay, and after that read in the complex numbers and do it. That's it with the second exercise. Now let me save this and quit from the editor, G-editor. I have come back to the terminal and now I'll execute and show you. Okay. So this is wherein I have to give the two numbers. So first I'm giving 3 plus 4 j, and coming to B part, I'm giving 5 and then I'm giving 2. Okay, so these are the two complex numbers. A is 3 plus 4j and B is 5 plus 2j. And then the addition is this, the real parts get summed up and the imaginary parts get summed up. Okay, 3 plus 5 is 8 and 4 plus 2 is 6. These operations and all, you know it. Okay, right. So this is how the um, addition, subtraction, multiplication, and division between the complex numbers happen. And this is the answer that the arithmetics produced. So that's it. This is the end of your second experiment. Are the two exercises clear to the class?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, somebody was asking me a doubt regarding where to write. Is your doubt clear, Ma, now?
Yes, ma'am.
Okay, well, fine. So let us move on to the third experiment. Your third experiment is to demonstrate decision making and looping structures in Python. So you know that, let me get back to the terminal G-editor to show you some textual information. So G-edit, so we are working with decisions. So I'll say decision.py. So wherein, can you see the G-edit screen, all of you?
Yes, ma'am.
So what is your program? Your program is to demonstrate decision making concepts and then the looping concepts. Okay, so it's very important for you if you want to grab a job. It's very important for you to be very thorough with the decision making and the looping structures. Generally, we have two ways of solving a problem. Okay, so one is to use the loops and the other one is to use recursion. Okay, so these are the two algorithm strategies. Okay, so algorithm, the way you write your algorithm will be either looping structures or to the sir. It's okay, comes. పర్వాలేదు ఒక్క నిమిషమే కదా. Girls, just 1 minute, please. Okay, girls. Okay, fine. Am I audible? Confirm. Somebody confirm whether I'm audible or not.
Yes, ma'am.
Okay.
Audible, ma'am.
Okay, right. So we have this decision making. Decision making actually will alter the flow of execution, alter the flow of path of the coding statements that will be considered. So if condition is true, then there will be a different path of statements, different set of statements that will be executed. If it is false, then different set of statements will be executed. So to actually put in the decision into your Python codes, we do have special decision making constructs. Those are if and then you have elif, you have so all these things are there, and finally you have else. These are the decision making keywords that are used for putting any decisions into your program. If can be alone, it needn't have an elif or else followed after it. It can be singly if over there inside your program, but else cannot be single inside the program. There should be if preceded to it, or else an elif before it. And elif cannot be alone again inside your program. Elif also need to have if preceded before it. So these are general rules that sir have already discussed in your theory part. So I'm not getting into the theory part of it because you already learned it clearly. So you can also do nesting of if, meaning that you can have one inside the other. If in the if block, you can also have an if inside it and an elif and else, everything can be there. So how many nestings you can make? There can be only one outer and one inner. No, you can have n number of nestings. But what happens is the more nestings that you make, the more complex your program becomes, and after some time it will become very complex for you itself to handle it. So it is always good that you keep the nesting of ifs as minimal as possible. So that's how you write your coding better. Okay, right. In your third experiment, they're asking you to demonstrate all the decision making statements like if, elif, and else, how they are used in the program. And writing the program, it's a general question. So you can write your own programs for if, elif, and else, but the thing is you need to demonstrate the use of it properly. Okay, this is the first part of your third experiment, and the second part of your third experiment is looping structures. Loops are used to actually repeat some set of code again and again. So at the same point, so you know the differences between loops and recursion. Both are used for repetition, but recursion is used to repeat the function again and again. Loops are used to repeat a set of instructions again and again. And to do that, you do have two constructs. The first one is while, and the second one is for. Okay, right. So these two are the looping structures that are available in Python, and these three are the decision making keywords that are available. So you can experiment on it. You can also have the decision controls inside your loops, and also you can have loops inside your decision controls. The either ways is possible. You can inside if you can turn a loop, or inside while you can have an if. Okay, so the combination of decision making and looping structures, one inside the other, is permissible in Python. Okay, right. So now let us look into the first experiment that I am showing you. So it is selection statements with elif and if, elif, and else. So first I'm reading in a string. So I'm saying C is equal to, so I'm just reading in a string. I need in typecast because by default the input that is taken is a string. So I'm not putting an int or a string or anything in front of it because I just wanted to read a string. So I'll say enter a string. And then so I have read the string. Now what I'll do is I'll check whether the string is all digits or all characters by using certain built-in methods. So I'm saying c dot is digit. So when I say c dot is digit, so it will check whether all the numbers are digits or not. Now you can see as I clicked on enter, so the cursor came below if. Okay, So whenever you're writing an if block, it is mandatory that you give indentation. So the indentation generally is 4 columns. So you just need to give the indentation like this. If it was your PyCharm IDE, then the indentation automatically comes. But if you're working in gedit and such kind of editors, nothing will be prompted. So you learn your subject also better. And the syntax errors will not be prompted, or nothing will happen over here. Nothing, it will not guide you, okay, according to the programming language. So when so there is no guidance, you will learn better, okay, because you if you are typing your print statement here or whatever, what happens is it will throw you a syntax error, because if block need to have an indentation, okay. So with the syntax errors, you learn it, okay, right? You need to give the indentation. So I'm giving 4 columns as the indentation. I'm saying print if this condition is true, then I'm saying the string is all digits. Okay, string is all digits. This is what I am trying to uh, show. Okay, and then I'm saying what is it? It is C, right? So I just wanted to print C, so I'm printing it. Okay, in the similar way, I want another condition over here. I can also simply put an if. Okay, what happens if I put an if is that this condition will be checked, and even if this condition is true, say that for example this condition have turned up to be true. If this condition is true, the statement will execute, and since I have given an if here, again the interpreter will check this condition here. But I don't want that to happen. Okay, I don't want the if here, because I don't want to check it if this condition is true. In that case, what we'll do is, rather than giving an if again, we'll be giving an elif over here. Okay, so which means that if this condition is true, then this elif will not execute for you. If this is false only, the elif will execute. Okay, so that is how the order of if and if, or if and elif works. So inside it, I'm saying is dot, so is alpha. So this is another method which will check whether the given string is all letters. Okay, so I'm giving an indentation again to make an elif block. So I'm saying print statement. Inside the print statement, I'm saying string is all letters. Okay, so string is all letters. And then I'm giving what is C also. In the similar way, you can also write an elif ladder. So you can have how many ever you want. You can have over here the methods, or if, or elif, any number of elifs you can have. So I'm giving one more elif for you to understand it. Okay, so I'm saying is alpha, is all num is the method. Okay, so which actually checks whether the given string contains letters and numbers. If it contains letters and numbers, so then if I'm saying that string contains both. Okay, so string contains both numbers and letters. And then okay, I'm printing it. Okay, fine. So this is a program. You can have an else, final else, or it's okay if you do not have it also. Okay, but I'm giving an else over here, which says if nothing is here, okay, check with some other string. Okay, so something I'm giving it that way. Check with some other string. Nothing matched. Okay, so nothing matched or whatever. Okay, so we are trying to write this code to demonstrate the decision controls, wherein I have used if, elif, and else also. Okay, all the three I have used. I can also have an if here. Okay, it's okay, totally valid, but provided that this else should be only at the end. Okay, so the else should be only at the end. It cannot be in middle of this if and elif and all that. Okay, so that syntactical concepts, you know it. and you cannot have an if after this elif. Okay, if only you should start your decisions only with if. If can be followed with an if, or else it can be followed with an elif, or it can be individual, or it can also have an else after it. Elif need to have if before it, but it is not mandatory to have an else after it. Okay, else can have an elif, or it can have an if before it. So these are all the syntactical rules that you need to follow while using if, elif and else. Am I clear on this?
Yes, ma'am.
Yes, ma'am.
Okay, now let us execute this and see various outputs. So I have saved my file. I quit. Can you see the terminal?
Yes, ma'am.
Yes, ma'am.
Okay, so inside the terminal, I'm executing this.
Colon, ma'am.
Yeah. Okay, so I need to enter a string. So let me enter a string which is having all the numbers in it. So 564. So you can see that it is saying string is all digits. Okay, let me get back to the program and show you how this functions. So I have given some number there, right? So first this condition is checked. Okay, so is digit condition is checked. So I have given all numbers inside the string. So string is all digits and I got that output. If this condition is false, now what I'll do is in my next checking of the output, I'll be giving all letters. Okay, and in that case what happens is each digit will return a false. So the condition comes to the control comes to the elif and checks for this condition again. So is alpha will be true now. So what it will do, it will print this string is all letters and the program will end over here. The control will not come to elif or else because this condition has become true. Once a condition becomes true in this particular ladder, that condition the block pertaining to that condition elif will execute and the rest of the statements below it will be ignored. Okay, so this all letters will happen. In the next output, I'll show you a combination of letters and numbers, wherein what happens is this is digit will return false and the control comes to the elif checking this condition and this condition will return false. So the control again comes to elif and checks this condition where this condition will return a true and it will print this. Okay, where the control will not come to this particular else part itself. Okay, right. So this is what is the program. Okay, now let us check the various paths of execution with giving different kinds of input. Now I'm giving another input, so wherein I'll be giving all letters. So I have given Sudha, so you can see string is all letters. Okay, there are no numerical characters, wherein the elif have executed. And let me show you another path of execution with different input. So wherein I said Sudha and I said 76. So you can see the string contains both numbers and letters. So I have numbers as well as letters inside the string. So you can see that with the kind of input that I'm giving, the path of execution have changed. Okay, so that's why we say that they are decision control statements. Okay, so based on the decision, the flow of execution, the path of the code that need to be executed will be decided. So that's why it's called as decisions. Okay, why we say that they're decisions is because of this. So with this program demonstration, you understood how to give the if, elif, and else part. Now let us see another program wherein I'll be showing you how nested if and else works. So let me take another editor, gedit file. So I'll be finding out the largest of all. So I'm saying large.py. So this is my file. So I'm reading in the input. I'm taking in two numbers which are integer type. So I'm saying input and then enter A. Okay, fine. So this is what I'm doing. And in the similar way, I'm reading in B also. Okay, so I'm taking in two numbers. We'll take three numbers. Okay, we'll take three numbers. So I'm taking A, B, C, and the algorithm is that we have to find out the largest of these three numbers that are read. Okay, fine. So I'm writing my logic here. So I'm saying if A is greater than B, and I'm putting a colon. So give the indentation, and then I'm having another if inside it. So if A greater than B is the outer if, and if A greater than C is the inner if. Okay, so this is what I have written. Okay, so inside it I am writing A is largest. Okay, or else I'll say A comma is large. Okay, fine. So this is what I have written. And then this is the else part. So inside the else part, I'm writing, I'll take this and put in here. So which means that A greater than B, or it's not greater than C, then the C is largest, right? Okay, so C is large. So this is my nested if. Okay, right. So else, because there are three numbers, I need to write one more conditions here. Because if B is greater than A, this part will never execute. So the control comes over here. So I need to write the logic pertaining to if B is greater than A. So if B is greater than A as well as B is greater than C, then we say that B is largest. So I'll say B is largest. So the indentation should be proper. Else, okay. So I'm coming to the else part here. C is largest, right? Right. So this is my simple logic, okay, wherein I just wanted to find out which is largest among the three given numbers. The three given numbers will be given by the user, and we are telling the user which is the largest. Okay, so I'm saving it and quitting from the editor. So I have come back to the terminal. So let me execute this and show you. So I said Python 3, and then I'm saying large.py. Okay, what happened? Yeah. I didn't give a okay quotes here. Fine. Okay, right. Okay, well, I just need to give the numbers. So I'm giving 5, and then I gave a 2, and then 8. So it's saying 8 is largest. Okay, so this is one path of execution where C is largest. Now let us check for where A is largest. So I'm giving 12, 3 and a 2. So you can see 12 is largest. And for the third case wherein I'll be checking for B is largest. So you can see 56 is largest. So my program is correct. You should not stop executing for one value. You should check whether the other logic is working or not. Okay, so I debugged all my if and outer if as well as my inner if else, and also second else, and also inside if and else. Okay, so everything, all the parts are checked. So my program is working absolutely fine, and this is how your nested if and else need to look like. So is the second program clear to the class?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so this is all about your decision making. In tomorrow's class, sir will continue with the looping constructs. So the third exercise is not over, right? So there is, because it's of two parts, your third exercise is of two parts. The looping, the decision controls, and the looping constructs. So it's already 10:30, so I'll wind off now today. And in tomorrow's class, sir will continue from the looping constructs. Okay, the third part, the second part of your third experiment. Okay, quickly, can you just tell me the numbers who are absent, or you will send a message to Seenu sir? What you will do?